Okay. Okay, welcome back everybody. I am going to stream a while here this afternoon. This is Jeff on the nybbles.io channel, and typically I stream Monday through Friday 5 a.m. to 10 a.m. Mountain Time. Going to try an afternoon stream here, and I'm also testing my WeChat configuration. I've got the Twitch chat here. Actually, I can just do a quick test. See if that, yep, working perfectly. All right, so we left off, and we gotten the some of the refactorings done around formatting the new data tables in the console, and I actually got the dynamic sizing thing, an initial cut of that going, and now I'm in the process of debugging it. One of the things I also did was write message. So there's now two overloads for write message. One takes a string and the flag, and that just calls the format text on the text formatter, and then passes it through to the main write line, which is now just based around the format text structure. So that means that from other parts of the code now, where we already have a formatted text T, we can just call this, and we don't have to go through the parser every time, which just, you know, made totally obvious sense when I saw the code and I would start thinking about it. I'm like, oh yeah, you know, we should do it that way. So I made that change. Let's see here. Okay, so then I think there's a bug though. I'm not sure. Let's take a look at this. So write message. Let's start here. For some reason, the reverse is getting reset right away. I'm not sure why that is exactly. Maybe because adder code is empty. Could be. All right, so that gets us past here. So now if I call symbols, so the formatted text that comes in, let's take a look at that, because this is a direct formatted text. So it's just a space. Yeah, I think I know what's causing it, right? So span, this one's fine, and this is going to come out right. But this one won't. Yeah, because it's an empty string. So we're going to say if the adder code is not blank, then we'll try to do it. So let's try that and see if that fixes that issue. Because what happens is when it goes through the text parser, reset blanks become resets, and reset, yeah, it ends up working differently. There we go. Look at that. Huzzah. All right, so then if I make it larger, symbols, there you go. Now, I have to work still on my little sizing thing there. Something's off a little bit. I'm not exactly sure what, but we're gonna take a look at that. I have a suspicion. I think the suspicion is I added code. We're adding an extra character here, right there. So there's a blank between one column and another. But in this case, we really shouldn't be adding an extra space after the last column because there isn't another column. So I think that's what the issue is. And so we could probably fix that. Let's see here. So auto column pad equal I is less than table here. J is less than row columns size -1. Then we're going to get a 1, otherwise we're going to get a 0. And then we just do a column pad here. Then the same is true, except I'm not incrementing it that way here. That's okay. I can change that. Let's see. What was I looking? Table headers. Sorry. Okay. So size T, I is less than table headers. And then this goes here. And this is and then the same thing is true for, also would help if I there we go. And the same is going to be true of the footer data row columns. So if it's the last column in the header, the data, or the footer, then we don't add a pad to it. But if it's any of the other columns, we put a space in between so that things don't butt up directly next to each other. Do symbols. Oh, now the footer's off by 1. But let's see what happens when we make it larger. It's close. Why would that be off? Now it's 0. Yeah. Well, looks right. Oh, because it's the only one, right? Which makes sense. Oh, but right, I see the issue. What's happening is there are more columns in the header, right? So if we had 3 columns in the header, this would be off by even more. So in the header, we have to track header padding, right? And then here, header padding plus equal column pad, right? And then down here, this is actually actually, there might be an easier way to do this. Plus table headers size minus table footers size minus 1, right? Plus header adjustment. So here we say auto header adjustment is this, right? So so whatever the size of the header is minus the size of the footer, and if header adjustment is less than 0, now because we should always have, we have to have one header, we have to have a column. There's always one. Footer may be 0. Now if footer is greater, we could just say max. No, I don't want the OpenCL one. That doesn't seem right. So if footers is larger than header, so we have one header, but we have 4 footers, we don't care, right? Because then the footer is going to be, well, then we have the reverse problem, don't we? I'm just curious to see if this even works. So header adjustment 0. Huh. I'm going to come back to that. That's a pretty minor thing. So it fits. So if I set foo equal to ff, 7f times 2, foo, and then of course that I haven't gotten to that one yet, but we will. And then I call symbols. There you go, symbols. Yeah, it's working. Very good. And if I make it larger, yep, it expands to fill. Very good. All right. So now we got the basics of it automatically sizes the footer. We need to come back and look at that. Oh, I wonder if the footer doesn't need that. I don't know. Let's see. Maybe that's my mistake. So symbols. Well, that looks better. It looks promising. There's probably just one extra character all the time. Would figure. Yeah, looks like it. Yeah, looks good. All right, not bad. So that was it. Ugh, sometimes, man. All right, there's. I was gonna do something important. And now I've completely... What was I gonna do? Okay, that's why it feels weird. I thought it felt weird. You know, I was like, why is it weird? So that's one problem. It's when it's doing the formatted text directly, it's overwriting that line that it's on. We're not moving down the line like the, oops, yeah, so that's not right. I don't want to do that. I guess we have to do it here, huh? It was something about it seemed off, and I couldn't put my finger on it, and it was because it was literally replacing the line of text that it was on, and it felt very strange. There it goes. Now it feels more normal. Yeah, there you go. And now we've got our extra. Yeah. Okay, so that one we still have. So so to be consistent, so we're going to do the new line at the end of the right message up until the last one. Ready will do its own line feed. So we get consistent spacing for everything. So symbols, there you go. Consistent spacing, consistent spacing. Now see in that one, like for clear, we don't want the extra carriage returns. So here, we're going to say new line. I guess what we could do is we could return something here. We don't want one here. Actually, I'm going to say we don't even, yeah, we can just say for all these actions. We don't need anything. We just so here we can do one. Otherwise, we don't do one. Right? Because for clear, we don't want it to push it down any. We want it to go right to the top. So, symbols. That's okay. We're going to work on that one. So clear all the way to the top. Perfect. Editor. Yeah. That's okay, I guess. I guess. Well, I doubt myself so much. And I go back and forth. What do I want to do? See what that looks like. That should be better. Hello, QWERTYs. All right, symbols, clear, editor. Yep. X. Yep. All right, so now, all right. Better, better, better. Don't need a pass result here anymore. All right, let's take a look at this one. All right, so if I do this, haha, look at that. Now it's getting truncated because it doesn't fit, but there you go. Now, here's an interesting bit, right? We can do multiple tables. So then the question is, should we? So this is like intrinsic or conversion table. And then we could have a, so this could be hex. And we know that we're gonna have 8, 9, so 9. We could do 10 and 10. Right? And then we have decimal. This got to be a bit longer. This is more like 20 and 20. And then we have ASCII, which is maxes out at 8. And then we have binary, which maxes out at what is 2 plus 33. So what do we have? It was 30, 63, and so 71. It's pretty big. I don't know. I mean, I guess the min on this is 3. The min on decimal is like 2. The min on ASCII is 1, 3, right? Because quotes. And the min on binary is 9. So 6, 15, 17 is the min. Like, so for a byte, right, that would fit. And we have to break this apart now, because or do this. Like that, and then results. All right, break this apart. Value format spec, and then we have string format spec. Oh, ASCII, sorry. ASCII format spec, and then binary format spec. Oh, let me exit this. Welcome, Somo Roker. Alright, let's see here. Almost got these. Alright. Oops. Yes. These are all going to be 0. Okay. ASCII and binary, which is just going to be value, I think is what I had. And then this is really decimal. All right, let me compare what I was using. What for what here? No, not evaluator. Environment. All right, so I was using 0 for hex. I was using 1 for decimal. I was using 2 for ASCII and 0 for binary. Yeah, okay, good. Binary then was signed. Okay. So now, for the conversion stuff, we populate our result table instead of formatting one big string. All right. And then down here, I'm going to go back to this. We're going to have our results table. And then the dumps, the data dumps, offset. Really the minimum here is, I I think I'm doing 32 byte, so 6, yeah. So 6 digits. So really, 6 is the min. I guess 6 is the max too. And so we're doing 2 times, I think 16? Yeah, 2 times 16. So 32 plus a space. So that's minus 1, 47, 50 characters, 47, 50 characters. So we'll do 47 and 47 here. I'm not sure. And we'll call this bytes. And this can be, I don't know, 20. It's probably pretty reasonable there. Now, of course, then the hex dump we need to format out that way too, right? We got to refactor it to return back columns. So for now, I'm just going to cheat and so then we need a standard value or standard vector of string. We're going to call that results. And we're going to pass that in here to all these. So that we can get a columnar data set, so that we can populate that into our new table. All right, so this guy is going to be results. No. Results. And for now, we're stuffing the whole dump in the bytes column, which I'm not, that doesn't feel 100% correct, but and of course, to do this properly, we need to create a parameter dictionary here and conversion table like so is okay. And then dump count This isn't, again, we're going to have to it's going to be dump count like so. Dump table. And actually, the way this is going to work, we're going to create, I'm going to create a dump table every time we do one, because we can now format multiple tables, so that actually ends up working. So there's one big conversion table. It just has all the conversions in it. So, but then if you have dumps, you're going to get special tables that just represent the address offsets and then the data bytes. But, yeah. I guess, so this is dump table, and then we're going to add it's going to be value.length. Let's see here. What can we listen to? All right, so let's see what it looks like. It's going to need tweaking, but that's okay. We'll do FF, 7F, 8, 0, and then this is a test. Okay, so there's our format, right? Hex, decimal, ASCII, binary, and 4 expressions evaluated. And then the offset data, or well, the data, rather, I should say, the 14 bytes. All right. So if we output multiple tables in console, which is right here, we want to put some space. There we go. So now we have a space in between the two of them. Good. Looking better. All columnar. All nicely laid out here. So let's look at our table here for decimal. Seems to be right aligning it. Oh, because that's what this guy up here is doing. He's right aligning, yep. He's right aligning it. So actually, the decimal format never goes above 10 digits. So I guess I can make my column much smaller. So if I go by this, yeah, the smallest decimal is a 3. I had just said 2. So 3. There we go. And then the smallest ASCII output is 1, 2, 3. I got that right. The largest is 1, 2, 6. So the largest output is 6. I put 8. Actually, 1 to 4, 6, 8. It's interesting. So really, yeah, because I 4 and 6. Interesting that hex is not right. It's being truncated. So D word is 8. I see. So 8 plus 9, so it's 9. I said 10 though. That's interesting. Let's try that. I wonder why it's... It's probably the min size. That looks better. Of course, I made it larger, made the window larger. So let's make the window a little smaller. So decimal is getting truncated pretty significantly, as is hex. So, yeah. I don't know. So if I push these up, Yeah, it's truncating it. Yeah, I mean that's the option you have right here is you can use the size specifier. Oh, I keep doing that. You can use the size specifier to get it to fit. If you need to support, if you need to see a D word, then you're going to have to make your window bigger. So, yeah. Oops. There it goes. Yeah, I mean, it all fits if you have enough horizontal room. All right, so now I just need to, other than the stupid footer thing, which we still gotta look at, well, let me do this. If I do Word, I didn't like that. All right, let me fix the hex dump so that it does the right thing. So who all calls? I think it's just the evaluator, yeah. On dump memory calls it. So that's okay. Because we're gonna update that guy too. So it's gonna be standard vector of a standard vector of a standard string. Well, results. So we pass a reference to that guy in here. All right. Okay, so we pass in a vector. So this is the row, this is the column of a stream. We change our thing here, so we create a line. We push the address, the offset, onto the line because that's a column. We create two streams, one for the byte, one for the ASCII stream. We loop through and we format the byte, and then we say, I don't know why we're not doing that here. So then we format the printable character or a dot into the ASCII stream. We push the byte stream column. We push the ASCII stream column. We add the line. And so then if I go back to environment here, I'm going to create a standard vector of standard string. Lines. I'm going to pass lines in like so. Missing bracket. Then we don't have a return type anymore. We just call dump and we fill it in. And so then we just need to, for every row, we need to, so it's offset data bytes. That's the footer. Offset data ASCII. And this is going to be 16 and 16. Right. So row and lines, right? Do this. And we're going to do const auto column row and actually do that, right? Yep. Okay. That should look better. Better. Yeah, this is our so I should be able to borrow this more or less. Bytes. I don't need this to be on separate line anymore. table here. No reason to have a different name. Okay. Okay. Let's see what this looks like. See how close we got. All right, symbols, does that still work? Looks okay. All right, so we're gonna do 7F, FF, 80, FF, 0. Ooh, interesting. Close. Close, close. Hello, Risico. How's it going? Let's try this again. Doesn't scan it correctly the second time. Oh, so I gotta type it. 7F, 80, FF. Okay, so if the screen's big enough, it fits. Yeah, if it's not big enough, it doesn't fit. Do that every time. Okay. Yeah. So, it works in both cases. It just, so I could make this smaller, right? I'm dumping 16 bytes. I could say, we could pass in the width. Doing good. Thanks for asking. Still working on these refactorings, but making good progress. Definitely making good progress. So hex dump, we could say bytes. Right, and we could say bytes and bytes, and the default we leave at 16, but I can't do that. That's all right. We can pass it in. It's not a big deal. So then in, environment here, we could just say we want 8 bytes, right? And then same thing for on dump memory. We just want to do 8 bytes across. Oh, actually, that's the one I just did. Huh. Make this one 8 bytes. There you go. And then that's going to shrink both of these, right? So 2, that's 16, 8, 24. right? And then this is 8 and 8. So it's going to make them smaller. Yeah, determination is hard to come by. I guess that, you know, for me, it's always been finding projects that I like. I really have to want to see it, want to get to the end, you know. Then it's much, much easier. But I appreciate you coming back, checking in. Yes, sir. Yeah, today's been a good day. A lot of stuff. There's, you know, a handful more existing implementations in environment for the commands that I have to get working, but or I should say refactor to use the new command formatting stuff. But it's not bad at all. So actually, I wanted to do this. Oh, right. It helps if I load a project. That's better. You know, that's not bad. It's more vertical, but that's okay. The UI ends up working that way anyway. So now, you know, I still, yeah, it's still not going to work 100% if the screen's super duper small, but that's okay. Nobody's going to, I mean, that's pretty small. Nobody's going to use it that small. Now I gotta fix the footer. The footer's still off. So let's try our evaluate. So FF7, F80, FFF, C00. Oh, that's actually a good one. And let's do some binary, and let's do some octal, and let's do a character. Oops. Yeah. That's not going to work. No, I have pushed to the GitHub. You need to look at the machines branch. I haven't merged any of this stuff into master yet. So check a look. So it'd be origin machines is the branch that you want to look at. That's the one I'm working on right now. So yeah, when you go to GitHub, at the top, there's a branches link. Click on that. You'll see the machines branch, and you can see the stuff I've been working on stream. So let's see, character A, character B. This is a really big data dumper. Formatting. Output is fun. Not fun, fun. There we go. Yeah, I mean, really, darn. It's not bad at all, man. Not bad at all. I just gotta fix the footer. The footer is really driving me nuts. I think I know what the issue is. I just maybe. I don't know if you saw this morning, but I got the state machine working in the console, so now I can do long-winded output, and you get a more prompt so that you can see what's there. So that's cool. Yeah, it's getting there. Okay, so I'm gonna commit this, review it and commit it, because the next round is going to be really fixing and refining stuff. So let's take a look. Right, so I refactored hex dump. You can specify the number of bytes across that you're going to get, and then we're going to dump. Instead of formatting a string, we're going to format columns that are going to be our output. And you know, the more I think about it, so I'm doing this stupid formatting thing here. And I'll be darned if... Of course, the problem is then I have to dynamically fill based on... Yeah, I'll leave it this way for now. Yeah, I'll leave it this way for now. All right, let's see here.
Random. No request, carry on. Okay. In that case,
I like listening to some
no
of
request coming, and
Lara
I'm gonna try and play like
6683's
all of them.
streams on YouTube. She's an amazing piano player.
Okay.
Yeah, I made a note of that. That the evaluator doesn't handle recursion very nicely. Right, so now numeric formatter dumps out an array, or populates an array instead of formatting a string, so we can use it inside of our tables. And then on evaluate, we've got our conversion table that we fill in. Then for data dumps for strings, we have a table, dump table that we add in, and we just keep adding that to the params dictionary, because now the console will dump all of the values that are in the params dictionary. I think my internet service provider finally sent somebody out here to bury the fiber optic cable. Right, so then inside of the H command, the dump memory command, we create a table. We use the same logic that we're using in the evaluator. And at some point, we can probably refactor that to be in some common conversion dealy. Okay, so that looks good. Right, and so then I added the adjusted width column so that the column scaler in console. So I added an override for write message that takes the formatted text instead of the string. So internally, when we create formatted text instances, we can use that instead of having to go through the parser, save some overhead. I got rid of format lines, format command changed, and then I added scale columns. You pass in the array of columns that we need to try to size to fit. This was my, first cut at this. I changed the signature for the functor for the command action dictionary. It returns Boolean. If it's false, then we don't issue a new line. If it is true, we issue a new line. That allows us to kind of control how the formatting works after those are invoked. I implemented the format pattern for centering text, so that works now too. Scale columns. The way this ends up working is we take the page width, we subtract 4 from it, because we don't want to go right up to the very last character in the on the page. We want to give a little bit of buffer. So that's our target width. That's what we're going to try to hit. I have a local lambda function here that I use kind of as a private function to compute our current working size of columns. And so then I have a while loop here, and I say, okay, give me the working size of the columns. If it's less than or equal to our target, we're done. Otherwise, we're going to loop through the columns. We're going to subtract 1 from the width of every column. If column width ends up being less than the min width, then we clamp it to the min width. And then inside of this, lambda, we set our working size to 0. We set our clamped count to 0. We loop through all the columns. If the width, so the width is this manipulated thing that we adjust, right, to get the actual width we're going to work with. If it's 0, we set it to the max width. That's where we start. If the width is equal to the min width, in other words, we've already come down and clamped to the min width, then we increase the clamp count. Otherwise, well, not otherwise, then we increase the working size by the column's width plus 1, because that's going to account for the extra space. I wonder if that's what's causing a problem. I don't know. I have to think about that. That could be. And then if the clamp count is equal to the number of columns that we have, then we go with the target width. In other words, we don't want to get into a spot where this thing just spins infinitely because we can never get below the size of the window. Otherwise, we use our working size. So that's how the sizing algorithm works right now. And then some pretty major refactorings in format command result. I don't pass resultant anymore. So before, the preprocessor was doing all this work, and I was converting all this formatting stuff into strings that would go into the result. So the existing formatter, result outputter would just dump whatever got populated in ahead of time. But that just, the more I thought about it, the less I liked it. Plus I thought, I already have the data structures. I don't need to convert them just so the code can convert them back. It would just make sense to just change, add an override for write messages so that I could pass the data structures in directly. Then inside of the table type, I call scale columns for the headers and the footers. So this adjusts the width of the individual columns. Yeah, I got to think about that some more. I'm starting to form a cogent idea of why the footer doesn't always format properly. The rest of this stays mostly the same, but I had to refactor to have some logic for whether or not to add a column pad. The other thing that I did was I added in a substring on the text so that it truncates it. Now, this was a first pass. What I'm also going to do in the next pass on the column, you'll have a flag whether or not you want a word wrap. And so, because I have code that will do word wrapping within a column, so then the next thing to do, if you say, okay, no, I don't want that to truncate, I want it to wrap, it'll add new lines and it'll wrap appropriately. So that'll come up next. And if we do that, that's going to help some of our overflow issues on really small screen sizes. Same thing for the data rows. Same thing for the footer rows. Same thing for all the other data types. Now it pushes out formatted text of T's. Formatted text T's. We add a new line here, and then we loop over our data structures and call the override of write message that takes the data structure. And if we're on if we're outputting any line that's not the last line, we add the extra new line at the end. Otherwise, we don't add the new line. This here, like I had changed the prototype with the lambda, so I check to see if it's true. If it's true, we do a line feed. If we didn't process any command, we do a line feed, and then we output the ready. And then here's our, this was the original function. I just took the calls to the parsing out, changed the prototype. The other thing I had to do here, because I'm generating raw formatted text T's and spans, I had to add a case here that if it's an empty adder code, not to try to do anything with it, because the parser was kind of handling that case for us. So there's a little bit of redundancy there. And then the string version of write message just calls the data structure version, but calls the form or the parser first, and then passes that through. So that's all good. All right. I will be right back. I'm going to take a quick break.
Nice one, Brian.